A trekker likes to trek on hilly trails. The time he takes depends linearly on both height and length of the trail. He takes 69 minutes to complete a trail with a height of 800 feet and length of 1.5 miles. He takes the same time for another trail of height 1100 feet and length 1.2 miles. Then, how long will he take to complete a trail of height 4000 feet and length 4.2 miles? It is given that time depends linearly on both height h and trail length L. That is, time t is equal to A multiplied by h plus B multiplied by L, where A and B are constants of proportionality. From the data given in the question, 69 minutes is equal to A multiplied by 800 feet plus B multiplied by 1.5 miles. Similarly, 69 minutes is equal to A multiplied by 1100 feet plus B multiplied by 1.2 miles. In both these equations, we have multiplied A with the respective height and B with the respective length in miles. As a side issue, can you guess what the constants of proportionalities A and B are? Are they dimensionless numbers or do they have their own dimensions? Look at any of the two equations above. Both sides of the equation must equal one another. That is, not only the numbers of both sides must match, their dimensions must also match. 2 bananas equal to 2 bananas, but 2 bananas do not equal to 2 pears. Also, we cannot add 2 bananas to 2 pears because then their sum has no valid dimension. But we can add or subtract quantities with the same dimensions only. One of the above equations is 69 minutes is equal to A multiplied by 800 feet plus B multiplied by 1.5 miles. The left hand side has the dimension of time. Therefore, the right hand side must also have the dimension of time. Now look at the right hand side. It has two terms with feet and miles. Though both are not the same, they both have the same dimension of length. And they can be converted from one to the other by a simple conversion factor. Again, look at the equation. 69 minutes is equal to A multiplied by 800 feet plus B multiplied by 1.5 miles. In dimension terms, the left hand side has the dimension of time and the right hand side is A multiplied by foot plus B multiplied by mile. For the right hand side to have a dimension of time, we must have the dimensions of A and B as time divided by length. Or A really is A minutes per foot and B is B minutes per mile. Since the dimension aspect is not highlighted in many learning places, I thought I would do so for you. Now we return to the original problem and recall that we had written the following two equations. 800a plus 1.5b is equal to 69. Let us call it equation 1. And 1100a plus 1.2b is equal to 69. Let us call it equation 2. Subtracting equation 2 from equation 1, we get 300a minus 0.3b is equal to 0. Dividing by 0.3 both sides, we get 1000a minus b is equal to 0. Therefore, b is equal to 1000a. Putting this value of b in equation 1, we get 800a plus 1.5 multiplied by 1000a is equal to 69. Or 800 plus 1500 multiplied by a is equal to 69. In other words, 2300a is equal to 69. Therefore, a is equal to 69 by 2300 or is equal to 3 by 100. Now, if you put the dimensions of a as we had found earlier, it will be 3 by 100 minutes per foot. And b being 1000a, that will become 3 by 100 into 1000, that is 30 minutes per miles. Remember, we have found out the dimension of b before. Then, when height is 4000 feet and trail length is 4.2 miles, the time would be t is equal to ah plus bl, that is equal to, when you put the values of a, h, b and l in this equation, we get 3 by 100 minutes by foot multiplied by 4000 feet plus 3 minutes per mile multiplied by 4.2 miles, that is equal to 3 into 40 minutes plus 3 into 42 minutes, that is 120 plus 126 minutes, and that is equal to 246 minutes. This is the answer. If you like the video, please like, subscribe, share and hit the bell icon so that you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later. Thank you.